Hi everyone. I'm Rivaya, and I took APBC in my junior year, and I just graduated from high school. And today we're going to be talking about shapes of curves, graph FRQs. So, um, basically, before we get into the questions, we have to go over a few rules, and it's really, really important that you know these rules and have them memorized. Otherwise, it's pretty difficult to answer the questions. But if you know the rules, you'll be perfectly fine. So the first rule is that f is increasing when f prime is greater than 0. So if we're looking at that graph, which my hand is covering right now, but in a second, f is going to be increasing whenever this line f prime is greater than 0. So this whole area is when f is increasing. And then f is decreasing when f prime is less than 0. So if you're looking at this graph, whenever this line f prime is below the x-axis, that's going to be when it's decreasing, when f is decreasing. So the next rule is going to be about concave up. So f is going to be concave up when f prime is increasing or when f double prime is greater than 0. So I'm writing it out there. But a quick note about f double prime, we're not going to be talking about that today or dealing with it, but it's just good to know. So it can be concave up when you have f double prime being greater than 0 or when f prime is increasing. So it just depends on what the question is asking for and what they give you. And then f is concave down when f double prime is less than 0 or when f prime is decreasing. So it's kind of important to just make sure you pay attention to like f and f prime, because it can get a little bit confusing when you're talking about when f is increasing or when f prime is increasing, because those are two different things. So f is increasing when f prime is greater than 0, and that's different from when f prime is increasing because it's just going up at that point. So now we're going to talk about local max and local min, and I'm just going to move over so y'all can see it. Whee! Okay, so f has a local max at x equals a if f prime goes from positive to negative at x equals a. So it's going to have a local max whenever it switches, when f prime switches from positive to negative. And then the next rule is going to be for the local minimum, or local max and min can also be called relative max and min. It's interchangeable, so don't get confused if you see something different because they mean the same thing. So f has a local min at x equals a if f prime goes from negative to positive at x equals a. So it's the opposite of a local max. And so these rules, just make sure you know them once again, because it is really important that you have them memorized. Okay, so the last rule that we have to talk about is at inflection points. So f inflection point has an inflection point when f prime goes from increasing to decreasing or decreasing to increasing. And then I also mentioned f double prime here. Hold on, let's get the full thing in view. So f has an inflection point when f prime goes from increasing to decreasing or decreasing to increasing. And it can also be when f double prime changes signs, but the graphs today don't involve f double prime, so we're not going to talk about it. But just make sure you have that stored somewhere. Okay, so now that we have all these rules, we're going to get into the first question. And they're all going to be based on this graph. So suppose that f is a twice differentiable function where the graph of f prime is shown below. Answer the questions about f on the interval 0 to 7 and justify your answers with complete sentences. So the format of like how I'm going to write the answers, it's going to be like restating the question with the answer, and then you write the rule and the justification. So the first question is asking, where is f increasing and where is f decreasing? So when we're looking at that, f is going to be increasing whenever f prime is greater than 0. So we would go to the graph and we would look wherever f prime is greater than 0. So it's greater than 0 from x equals 4 to x equals 6. So the interval is going to be 4 to 6. So when you're writing the justification and the answer, you would write f is increasing on the interval of 4 to 6 because f prime is greater than 0 there. So that's all you have to write for that question. It's pretty simple, and you can answer it very easily if you know your rules. So then when we're looking at where f is decreasing, f is going to be decreasing whenever f prime is less than 0. So if we're looking at this graph and we want to see where f is decreasing, it's going to be whenever this line f prime is negative. So it's below the x-axis from 0 to 4. And then it's increasing at this point, so we're going to take that out. And then it starts decreasing again from 6 to 7. So that's all we need to do for question 1. So I'm showing the graph again, and now we're going to go into question 2, which is asking where is f concave up and where is f concave down. So f is going to be concave up on 3 to 5, on the interval of 3 to 5, because that's when f prime is increasing. So f is going to be concave up on 3 to 5 because that's when f prime is increasing. So it's increasing from here to here. So just make sure you don't confuse that when f is increasing, because f is only increasing when f prime is greater than 0. So it's only increasing here, but f prime is increasing from here to here. And then when we're looking at when f is concave down, f is going to be concave down when f prime is decreasing. So f prime is going to be decreasing from 5 to 7 because the line itself has a negative slope and it's just decreasing. So that's all you have to do for that question. Question 3, we're looking at the graph again. At what x does the graph have a local minimum and local maximum? So let me get a picture of the graph. Hold on. Sorry. Okay, there we go. There's a clear picture of the graph. So it's going to have a local minimum when f prime is going from negative to positive at a point. So when you're looking here, f prime is going from negative to positive at 4, because that's when it's changing from negative to positive. It's going past the x-axis. And then when we're looking at a local max, it would be whenever f prime goes from positive to negative. So that would be at 6, because it's going from positive to negative. It's going from above the x-axis to below it. So we're just going to write out the justification and the answer. F has a local minimum at x equals 4 because f prime goes from negative to positive there. And then f has a local max or maximum at x equals 6 because that's when it's going from positive to negative. Okay, fourth question. At what x does f of x have an inflection point? So if we go back to the rule, we know that an inflection point is when f prime goes from increasing to decreasing, or it goes from decreasing to increasing. So we'll have to just see on the graph where that would be. So let's get a picture of the graph again. Sorry. Okay, so we have the picture of the graph there, and we're trying to figure out where the inflection point would be. So when you're looking at this graph, you would see wherever f prime is changing from increasing to decreasing. So don't think about like positive, negative, because that's going to confuse you, and you're going to start thinking about when f is increasing, but f prime changes from increasing to decreasing, the slope changes, at x equals 5. So that would be your answer. And then rewriting the justification, you would say f has an inflection point at x equals 5 because f prime goes from increasing to decreasing. It literally changed at that point. Okay, so first page done, and now it's time for the second page. And you'll notice that on the second page, it's combining things because the questions on the first page are a little bit simpler. So they're just going to be asking 2 questions at once, and you're going to have to combine a few rules, but it's not that much harder than what we were doing on the first page. So that's our new graph. And now we're looking at where f is increasing and concave down. So we want it to be both of those things. So once again, the rule for when f is going to be increasing whenever f prime is greater than 0, and it's going to be concave down when f prime is decreasing. So we're going to try to find where f prime is greater than 0 and when f prime is decreasing. So if we look at the graph, we'll see, let me pull up the graph, hold on, there we go. When we're looking at the graph, we're going to see, so f prime is increasing. Just take it one step at a time. It's going to be increasing in this area, at this interval, from -6 to -4, and it's also, f prime is positive, sorry. F prime is greater than 0 from -6 to -4, and from 4 to 6. So that's when f is increasing. And then we want to see where it's concave down. So in order to be concave down, it has to be, f prime has to be decreasing. So f prime is decreasing from -6 to -4, but it's increasing from 4 to 6. So the interval of 4 to 6 only meets one of the requirements, so that's not going to be the answer. So our answer is -6 to -4 because f prime is greater than 0, and f prime is also decreasing. So we'll just write our answer. F prime is decreasing there, and f prime is also greater than 0. Okay, so there's a picture of the graph again. Just making sure we have a picture. So the next question, what are critical points of f of x, and characterize each as a relative min, relative max, or neither. So relative or local are interchangeable. So this question is going to be a little bit longer, and it's going to have a longer answer. So the first thing we want to do is we want to find where our critical points are. So let me just get a clear picture of that graph. There we go. So f is going to have a critical point whenever f prime is equal to 0. So that's basically the rule. We didn't write it up there, but just know that your critical point is whenever f prime is equal to 0. So just looking here, f prime is going to be equal to 0 at x equals -4, x equals 0, and x equals 4. So those are your 4 values. So we're just going to write that down. And you have your justification there too. Okay, so now we want to take on the next part of the question, which is characterize each of those critical points as a relative min, relative max, or neither. So if we go back up to the graph, oops, oh no, okay, there we go, oh, There we go. So now let's talk about relative min first. We know that relative min is when a graph goes from negative to positive at a point. So we're going to see here wherever it goes from negative to positive, and we have our 3 points, negative 4, 0, and 4. So it's going to be a relative min at 4, because that's when f prime is changing from negative to positive. So we're going to go and write the justification for that. F has a relative min at x equals 4 because f prime changes from negative to positive at that point. Nice. Okay, so now we're going to look at relative max. So let me get a picture of the graph again. Okay, so f is going to have a relative max whenever f prime changes from positive to negative. So when we're looking here, f prime, which is the line, changes from positive to negative at negative 4, which is one of our critical points. So it's going from positive to negative, which makes it a relative maximum. So let's skip ahead, and there we go. F has a relative max at x equals negative 4 because f prime changes from positive to negative at that point. Sorry, my pen ran out of ink there, so just gotta make a quick change and we'll keep on writing. And now, after this question, we're going to have to, we have still one critical point left to talk about, which is 0. So when we look at the graph, let's try to get a picture of the graph again. You're going to see that 0 has neither a relative minimum or a relative maximum at 0 because it does not change signs anywhere. So let me get a picture of the graph coming up. Oh, sorry. Hold on. There we go. Oh. So I'm showing the answer first, but that's just what you would write. So you do have to put a justification if you're going to say neither, but you would just write that it doesn't satisfy the other two. Okay, so as you can see at 0, it's not changing signs. It's staying negative under the x-axis the whole time. Okay, now question 7. At what x does f of x have an inflection point? So an inflection point is when f prime goes from increasing to decreasing or from decreasing to increasing. So let's get a picture of the graph again. There we go. So we're just going to have to see, once again, where f prime goes from increasing to decreasing or decreasing to increasing. So just starting from the left, you're going to see that the first point where it changes is at negative 2 because it's a negative slope, and then it changes to a positive slope. So that's your first inflection point. And then as we continue, your second inflection point is going to be at 0 because it's changing from increasing to decreasing. So remember, it's not positive or negative. Don't get that confused because it's going from increasing to decreasing. And then your third point is going to be at 2. So this can get a little bit confusing because it's like not a normal point as you would think. Like it's not sharp. like pointy, but like it's still one of your inflection points because the direction of the line is changing from decreasing to increasing at x equals 2. So we would go down and fix your page and start writing the justification for this question. So our 3 points where there's inflection point would be -2, 0, and 2. And you don't specifically have to say for each one like its inflection point because at -2 it was going from here to here, and then at 0 it was going from here to here. You can just list your 3 inflection points and then just write it's going from decreasing to increasing or increasing to decreasing. Sorry, I'm a slow writer. All right, last question, yay! So, if f of -2 is equal to 5, find the equation of the tangent line of g of x equals f of x plus x squared at x equals -2. So this question is a little bit different from what we've been doing, but it you need to know the same information and it's pretty easy to solve. So when we're looking at this question first, we want to basically have all the components to make an equation for a line. So first we're going to want to find the y value. So in order to find the y value, we're going to take this equation here and we're going to plug in -2 into it. So when we do that, g of -2 is going to equal f of -2 plus -2 to the second power. And there's the graph, just looking at that, even though we're not going to use the graph right now. Okay, so the answer to this would be 5 plus 4 equals 9, because f of -2, you might be asking, oh my god, how did you get that? They gave it to us, it's right there. So f of -2 is equal to 5, and then -2 times -2 is equal to 4. So 5 plus 4 is 9. So your y value, g of -2, is equal to 9. And now we want to find the slope of g. We want to find the slope of g, and the slope of g is going to be the derivative. So g prime of -2 is going to equal f prime of -2 plus 2x. So f prime of -2, we weren't given anything, but we have a graph. So when we go up and look at the graph, let's see if I can find it. Give me a second. All right. So in order to find where to find what the value of f prime of -2 is, we're going to look at this graph. So this is the line of f prime, and at -2, the point is -2. So your y value would also be -2, and that's what you would plug in to your equation. So f prime of -2 is equal to -2 plus 2 times -2. And that's going to give you -6. So now we have everything we need to write the equation of the tangent line. And you would use, okay, let's write that out. Okay, so it would just be y minus 9, which is the y value we found, equals -6, which is the slope, which we got from g prime of -2. Let's go back, sorry, I don't know if you can see that. Y minus 9 equals -6 times x plus 2. And because they gave us x equals -2. So that's the end of this worksheet. Thank you for listening. Bye.